What's going on, YouTube? Today's episode is brought to you by the word try in geometry. Today we are focused on page 6 through 8, and we're going to be going over similarity statements. So I hope you enjoy. All right, so if you are watching this video, that means that you should have gotten through pages 1 through 4 in our notes. Now, we're going to use what we learned there to now answer these essential questions, which is, what is the criteria necessary to prove that two triangles are similar? So there are three ways that we can prove that triangles are similar: through AA postulate, side theorem, and side angle side theorem. So I'm going to go through each one briefly. AA postulate, AA stands for angle, angle. Two triangles are similar if they have two pairs of congruent angles. So you want to look at one triangle compared to the other triangle. So A has this one arc through it, so does D. So those ones are congruent. So we have at least one angle that's congruent. Then you have B, which has two arcs, and E, which has two arcs, so they are congruent. So that would prove AA postulate. A little fun fact for you is that if two of the angles are congruent, that means the last angle would also end up being congruent. But you just have to find two to prove that they're similar. The other one is the side theorem. This one says two triangles are similar if they have three pairs of proportional sides. So what you want to do is see if they're proportional. So you want to match up sides with each of the triangles. So let's say if I went with AB, that's 20. And then you have AB goes with DE, so 20 over 10. If I simplified that down, I would get 2. So that means all the other sides would also have to have that same proportion. So if I did this, I would have 14, and that one goes with the 7. Well, that in fact does equal 2. And then the last one, 12 over 6, that also equals 2. So this one checked out, and it's side theorem. Then last one here is side angle side theorem. Two triangles are similar if they have two pairs of proportional sides with a congruent included angle. So both sides that match up have to be congruent, and they have to have an angle that is congruent. So, the sides have to be proportional. So the sides, if I did this one, AB was 30. 30 correlates with DE, which is 10. So if I simplified that down, I get 3. The next side I had, BC, is 18. 18 correlates with EF, which is 6. That also equals 3. So the sides are proportional. Now I just have to check that they have an angle that is congruent or the same. And they do. They both have an angle that is 53 degrees. So that would prove side angle side theorem. All right, so now we're going to use those postulates or theorems that we just went over. So number one is saying the triangles shown are similar. So you're already told that they're similar. Complete the following. So you have two different triangles. So A, B, C, and C, E, D. So what we want to do is I'm going to first look to see if there is something that I can already assume. Now, the things that we can assume if we see it in a picture is vertical angles and reflexive sides. Now, this one has vertical angles. So vertical angles are the angles that are directly across from each other, and they're going to be congruent. So I know the angle for both of these triangles is going to be congruent right here because of vertical angles. Now, I don't know any other angles, so I'm not going to be able to use angle-angle postulate. So I'm either going to be using side-side-side or side-angle-side. So since I already have an angle, I'm probably going to be using side-angle-side, but we have to prove it first. So we have to make sure that they are proportional. So the sides have to be proportional. So let's say if I did from A to C. A to C is 15. What correlates with A to C is C to D, and that is 5. So 15 over 5 equals 3. So that means this other side is also going to have that same exact proportion. So I'm going to do from B to C, 18, over C to E, which is 6. And that also equals 3. So I have found that these sides are all proportional. So now I will end up being able to know that triangle ABC is congruent with the other triangle because of side, angle, side. So the last thing that we want to make sure that we do is go ahead and say in the correct order what ABC goes with. So ABC is similar. So this little, when it has just the squiggly, that is telling you that they're similar. So AC went with CD. So A goes with D. B goes with E. And they both use the point C, so that will be the last one. So we got to make sure that we do it in order. And something that I just noticed I forgot was I should have made sure to draw a triangle right next to it. So that is how we do number 1. Okay, so for number 2, when we look at number 2, you have the triangle LMN and then this triangle NPQ. I am trying to see if they are similar, and if so, give a reason. When I'm looking at this picture, there's one specific thing that I want you to notice, and that is these little filled in triangles. If you don't remember what that means that these lines are parallel. And when they are parallel, something that I've said in my class to like really emphasize that is I like to extend those lines. So I know those are parallel lines. And that would mean that the lines inside are the transversal, or the lines that cut through parallel lines. So another thing I'm noticing in this one is that they don't give us any side values. So since there's no side values, I know I'm not going to be using side, side, side. And I know I'm not going to use side, angle, side. So the only one that we could potentially use is the angle, angle postulate. Now, in order to use it though, I have to find some angles that are congruent. Well, just like in number 1, I do notice something that I can assume. I can assume that these are vertical angles. And if they're vertical, I know they're congruent. So I found one angle. So now let's try to find another. Earlier I said that these were transversals. So chances are we're going to be able, using these lines, to find an angle relationship. Now the angle relationship, I want to make sure I find one that's inside the triangles. So let's say if we went with P. An angle relationship that I could use with P would be with M. And the reason I know that those would be congruent is because those are alternate interior angles. So these are alternate interior. Since I've seen that, I have now done our AA postulate. So I know that these ones these triangles are similar because of AA. Now what I want to do though is go ahead and do my similarity statement. So triangle LMN is similar to, so L goes with Q, M goes with P, and then they both share N. So that would be my similarity statement. So I'm making sure that I go, the order of it matters. So using the markings that we made in the picture, we are able to see which letters go with which. All right, so page 7, I'm wanting you to do practice. So I want you to try to do this page and do it yourself and then ask me in class if you got all the correct answers. And if you have any questions, of course, feel free to ask me. But there is one that I want to go over with in particular, because I think we would struggle a little bit with this one. And that is part D on page 7. This one, notice that the triangles are inside of one another. So you have this smaller triangle STP, and that's inside of the big triangle PRQ. Now there is a marking already in there. They have angle S has one arc and angle Q has one arc. So that's telling me that those ones are congruent to each other. Now I am trying to find a similarity statement, and there's nothing about sides in this problem. So that means the only statement I can be looking at is really just the AA postulate. So in order to do the AA postulate, you have to have two angles. And right now we've only found one angle that's congruent in both. But there's something I want you to notice. They're both inside the same triangle. So they both use angle P. If they're both using the same angle, then it must be congruent for both triangles. So this one we were able to prove using angle. So we were able to prove that they're similar because of angle. Now what we want to do though is also write a similarity statement. So let's do the big triangle first. So I could do P, Q, R. So triangle PQR is similar, so that's that little squiggly, is similar to triangle, now they both used P, so I'm going to start with P. And we said from the markings that Q went with S. So that means I would have P, S, T. So that means T would go with R. All right, so home skillets. I'm looking at page 8. Now, the one I'm specifically looking at on that page right now is number 4. We're trying to figure out if the triangles are similar. If so, state the similarity and the postulate or theorem that justifies your answer. So we're going to write a similarity statement and say what postulate or theorem. Now on this one, I'm actually going to show you a couple ways that you can figure out what if they're proportional to each other. So this one, they only gave us sides, and same thing for the smaller triangle. So I'm going to do a proportion to see if we can potentially use the side theorem. So 35 would go with 10. So I'm going to do 35 over 10. The other 35 would also go with that. So 35 over 10. And then the 28 would go with the 8. So something to notice, I made sure that since I started with the bigger one, that the bigger triangle always was in my numerator, and then all my smaller ones were in my denominator. So you want to, it doesn't matter if I would have put this in the numerator, but you just want to make sure you're uniform throughout. All right, so right now what I'm going to do is GCF, greatest common factor. Figure out the biggest number that can go into each of these separately and make it smaller. So this one, the biggest number that can go into both would be 5. Same thing for this one because it's the same exact equation. Now this one, 28 over 8, I'm going to have to do a different one for that one, and the biggest number that can go into both would be 4. So if I did this, I would get 7 over 2, 7 over 2, and 7 over 2. So all sides are proportional. Now I'm going to show you another way to do this. The other way is to not even do GCF. This way would be just to actually divide them and see if you get the same number. So if I did that, I would have 35 over 10. That would get me 3.5. Now, one of them again was 35 over 10 as well. So that would also come out as 3.5. Then you have 28 over 8, and I would get 3.5. So either way proves that they're proportional. It's just however you like to do it. So we proved that they're proportional by side theorem. Now we also have to write a similarity statement. So our similarity statement, triangle, let's do LJK. LJK is going to be similar to, since I started with L, Z goes with L, so I'm going to do triangle Z. J goes with X, so X, Y. Okay, so most of these I want to be practiced for you, but there is one more that I want to do with you, and that's number 8. Again, we are going to find out, are they similar? If so, write the similarity statement and the postular theorem that justifies your answer. So I want to make sure that you know how to figure out like which side goes with which when you're trying to figure out like side or side angle side. And so if I look at the longest side RP, this longest side is going to have to go with the longest side over here, which would be FD. So when I'm checking for similarity, what I want to do is do this one here, 30, and put it over what it correlates with, which is FD 25. Now, when I do this, I want to do my GCF. The GCF for this one would be to divide it by 5. So when I divide each one by 5, I get 6 over 5. So that means the rest of the sides would also have to have this ratio for it to be similar. Now, so I did the longest side with the longest side. Now let's do the one that's in the middle. So this one, 24. So I have 24 over, and 24 is going to go with the next biggest one here, which is 20. So now I find my GCF, and the GCF for this one would be 4. So I'm going to divide each one by 4, and I'm going to again get 6 over 5. I'm going to go ahead and check the last one, and the last one I have 18. So I'm going to do 18 over the smallest one here, which is 15. And I'm going to do the GCF of 3. And again get 6 over 5. So I can actually, just by doing the all the sides being similar, I could actually say side, side, side for my reason why they are similar. Now they also gave me an angle, so I could have actually also used side, angle, side, because they both have this angle of 37. So you could, because all of them were similar, either one would have worked in this case. Now we also want to write our similarity statement. So let's say triangle PRQ. That one is going to be similar to, so the P goes with D. Now remember that for PR, that was our longest side. So if I started with D, that means I would have to go to F. And the last letter would be E. Thank you again for watching. More videos to come. Smash that like button, ring that bell, make sure you get all my notifications, and goodbye.